All right, let's make a start. So before we actually start the class, I want to have a quick activity first. So basically introduce yourself. So I'll start first. So my name is Sam Mao. So that's my name on the whiteboard. And I have like automotive engineering background. Basically, I finished my bachelor degree in automotive engineering at MIT from 2015 to 2018. And then 2019 to 2023, I had some research work. And then I'm doing Master of Teaching Secondary at University of Melbourne. Okay, so that's pretty much my background. I would like each of you to spend like 20 to 30 seconds to introduce yourself. Who want to do first? All right, maybe Justin?
Justin.
Yes?
Scotch. I like playing games. Yeah, I don't like.
Okay, that's fine. It's okay. All right, next one. Emily?
My name is Emily. I go to PLC in year 9, and I like playing tennis.
Tennis, okay. Noah? Yes. Okay. Next one.
Sean, I go to dumbbell and I like mountain biking.
Oh, mountain bike. Okay, cool. Cool. Okay. All right, now let's make a start. So we're gonna start from module 2. Okay. We're gonna start from module 2. So basically, if we have 3 lessons for module 2, and the module 2 is about all these basic functions. Okay. So this is the one you have in hand. Module 2 is algebra and graphing techniques of power, exponential, and logarithm function. Okay. It's basically, this is the very like fundamental topic for math method before we like dive into transformation or combination of function or inverse function. These are just the basic. So at my talent, we use modulus basically to cover all the topics in math method. We have totally 12 modulus, okay? Module 1, 2, and 3 is about algebra and graph. Module 4, 5, 6 is function properties and operations. Module 7 and 8 is calculus tech and application, like differentiation, integration, and things like that. And module 9, 10, 11, and 12 is a probability and statistics. Okay, so today we start from module 2, okay? As I said, module 2 is the basic. If you cannot like understand module 2, you will struggle in module 4, 5, and 6. 7 and 8, it depends, all right? And the next thing I want to explain is that's VCA math method curriculum. So area of study 1, 2, 3, 4, totally 4 study areas. Area 1 is function, relations, and graphs. Area 2 is algebra, number, and structure. Basically, we combine all the topics in area study 1 and 2 into 6 modules. Basically, area of study 1 and 2 corresponding to module 1, 2, 3, 4, 5, and 6. Area study of 3, calculus, is module 7 and 8. Area study of 4, data analysis, probability, and statistics, is module 9, 10, 11, and 12. That's the structure of this course. Any questions? No? Okay, cool. Now I'll explain the difficulties. So we have medium difficulties, high difficulties, low difficulties. Okay, let's start from like low difficulties. Basically, low difficulty means it's just common question type in the exam. Medium, okay, medium is exam don't test it in a straightforward fashion. Basically, it will not just test, for example, index law. You won't see any question, just test your index law. Okay, but to solve a particular question, you need to use index law to solve. Okay, so questions are usually basic, high difficulties, basically associated with a difficult question in the exam. Basically, you need to combine all the topics, all the knowledge, all the principle formula you learn to solve a question. Okay. So for module 2, we're gonna learn power, exponential, and logarithm. Basically, for example, y is equal to square root of x, y is equal to 2 to the power of x, or y is equal to log e through x minus 1. Okay, these are just some quick examples. So today we're gonna start from the very basic things to build up your concept and knowledge. Then we're gonna move forward to the more difficult things, all right? So basically, let's back to here. When you learn functions, pretty much you need to learn from two perspectives. One is called algebra. Okay, algebra basically include substitution and, for example, solving and rearrange. Okay, that's one perspective, algebra. The other one is graphing. Basically, you plot your graph, right? Basically, when you have a function, you have like algebra relations, things like that, and also graphing, okay? Module 1 is about polynomials, and module 3 is sine, cosine, and tangent. Okay, let's move on. All right, for lesson 1, basically today's lesson, we need to know the different operations. P for power, that's power function. E for exponential. Okay. Introduce the difference, the definition and the origin of these operations, algebra rule, and graph sketching. Okay, that's pretty much what we're gonna cover in today's lesson. All right, let's make a start. That's official start. Okay. So for operation, we have two types of operation. One is unary operation, the other one is binary operation. Okay, so what is unary operation? Basically, unary operation is a process of which a variable becomes another variable through an operation. All right. And it's one thing I want to emphasize. This variable, does anyone know the difference between variable and unknown? You will have, okay, after this lesson finish, I will upload this on the, I can't remember, but you will get my notes. You will get these notes. All right. Anyone knows the difference between variable and unknown? Any idea? No? Okay, so basically, unknown corresponding to one number. Okay, and variable corresponding to a set of number. All right, that's the difference between variable and unknown. Okay, now let's get into unary operation. Okay, so what is unary operation? For example, x plus 3 equal to y. Okay, how we describe this? X through plus 3 basically is addition, becomes y. All right, x over 2 is equal to y. That's the second example. X through 2 divided by something becomes y. Square root of x is equal to y. X through square root of x, basically that's a root, becomes y. Okay. Basically, a process which a variable becomes another variable through an operation, just one operation. Okay. And the next one is binary operation. So binary operation, basically a process in which multiple variables become another variable through an operation. Like basically, we have x, y, and z. We have how many variables? So in this case, we have x is a variable. But in this case, we have two variables. One is x, the other one is y. So see here, we have x, that's the unary. So x is input. X is input. And y is output. Okay, x is input, y is output. But for binary operation, we have x and y as input and z as output. Basically, we have two input, all right? Basically, x and y through a plus, x and y through a division, and x and y through a square root. Okay, that's binary operation. These are just some concepts. All right. Now let's move on to here. So in math method, basically math method wants to simplify the operation logic. Hence, it's sure that we only learn input and output, one input and one output operation. Okay, basically we don't need to worry too much about binary operation. Okay. Okay, but you need to know the difference. You need to know the difference. Okay, but for method, we just worry about one input and one output operations. Okay, does it make sense? Any questions? Okay. Basically, let's have a look. Square root of x, a, and 3 square root of x is unary. Y square root of x is binary, right? That's the difference. That's the difference. Okay. And the first example, basically, we interpret. Okay, let's read the question. Example 1. Interpret x times y, 2x, and y times 3 in terms of variables and operation. Okay, so basically for the first one, how we interpret that? Basically, it's two variables, x and y, undergo operation of multiplication. Okay, that's how we interpret this. 2x basically is one variable x, undergo operation times 2. All right. Y times 3 basically is one variable y, undergo operation times 3. That's how we interpret these things. Okay. If you don't have enough time to copy these notes down, that's fine, because I will Betty will send this file to you, okay, after the class finish. Okay, next one. Inverse operations of unary operation. Okay, so we talk about inverse operation. What is inverse operation? Basically, if we have x plus 3 is equal to y, x plus 3 equal to y, basically x through plus 3 becomes y, right? So the inverse of this operation is y minus 3 equal to x. Basically, y through minus x becomes x. So okay, so these two are inverse operation of each other. Okay, so let's say, for example, use z as the output, find the inverse operation of x plus 1 and y minus 2. So basically, x plus 1 is equal to z. The inverse operation, z minus 1 is equal to x. So plus 1 has an inverse operation of -1. And y minus 2 is equal to z. So z plus 2 is equal to y. Okay, so basically -2 has an inverse operation of +2. Okay, that's for addition and subtraction. For multiplication and division, we have, let's say, use z as an output, find inverse operation of 2x and y over 3. So basically 2x is equal to z. So z divided by 2 is equal to x. Y divided by 3 is equal to z. Z times 3 is equal to y. So that's inverse operation. These are just some concepts. The knowledge itself is not very hard, but you need to make the concept clear. All right? You need to make the concept clear. So basically, that's inverse operation. For the math method, I think we only consider the linear operation. Linear operation basically is a plus, minus, times, or divide by a constant. Okay, that's linear operation. Let's say something minus a, something plus a, something divided by a, something times a. A is basically we use a represent constant. That's linear operation. Another example, if we have something plus x, is that a linear operation? Hands up if you think something plus x is a linear operation. Hands up if you think something plus x is not a linear operation. No one? Justin, do you think it's a linear operation? Something plus x? Can you remember the definition of linear operation? Okay, so basically, linear operation is you plus, minus, times, or divide by a constant. So is that plus, minus, divide, or multiply? Is that one of them? Yes. Is the x a constant? We generally use x to represent constant? No. So it's not a constant, so it's not a linear operation. All right, that's the definition of linear operation. Plus, minus, times, or divide by a constant. X is not a constant, so something plus x is not a linear operation. All right? Okay, now let's move on. The next one is multiple ordinary operation and its inverse, right? For example, 3x plus 2 is equal to y. So the reason it's multiple operation is because x through a times 3 and then add 2. So basically you times 3 first and then you plus 2. So that's multiple operation. Inverse, basically you kind of like rearrange the equation. Y minus 2 divided by 3 is equal to x. So basically y through minus 2 and then divided by 3 become x. All right. And then let's go through this example together. Use z as an output to find the inverse operation of 3 minus x and 5 divided by x. Okay. The first one, 3 minus x is equal to z. So basically x through x times minus 1, because you have x. Jesus. So you have x as your input, but here we have the negative x. So basically you times -1, and then you have negative x, right? And then you add 3. Okay, that's the first step. You're gonna add negative x, and then you add 3, which give you 3 minus x is equal to z. Okay, that's operation. Okay, so the inverse of that operation is z through minus 3, and then divided by -1, you have x, right? Same with 5 divided by x is equal to z. Okay, x through 1 divided by the variable, and then times 5 becomes z. And the inverse is 1 over x over 5 is equal to x. Z through divided by 5, and then 1 over variable, 1 over the thing, and then becomes x. Okay, that's operation and inverse operation. These are just concepts. These are just concepts. Any idea? Sorry, any questions? Any questions regarding this inverse operation concept? You will use these concepts for module 4, 5, 6 study. All right, you will use these concepts in module 4, 5, 6 study. All right. Okay, next one is power operation. Power operation. So basically, previously we have 1 over something. Okay, 1 over something is not it's not actually a linear operation, right? For example, 1 over x basically is 1 divided by x. Is that a linear operation? X is not constant. Is that a linear operation? No, right? So 1 divided by a variable is not a linear operation, right? It's not a linear operation because x is not a constant. Okay, but we can write this. One over x is x to the power of -1. Okay, anyone has issue with this? 1 over x is equal to x to the power of -1. No, are you okay with that? Okay. Okay, but x to the power of a is a power operation. All right, x to the power of a is a power operation. So its inverse operation is still power operation. For example, let's say x to the power of 3 is equal to y. So x through a power of 3 becomes y. The inverse, y through a power of 1 over 3 becomes x. So still power operation, right? The next one is exponential operation, right? For something to the power of something, for example, x to the power of y is binary operation. But because y is a binary operation, x to the power of y. What's the definition of binary operation? How many variables? Are x and y variables? Do you remember we generally use a, b, c for constant, or x, y, x2, y1, y2 for constant? and xy for variables. So x to the power of y, basically we have two variables, right? X and y, they both variables. So it's a binary operation, but x to the power of a, x or a to the power of x to the power of a. How many variable in this x to the power of a? Which one is variable? X or a? Remember, generally we use, yes, x is variable. We generally use a, b, c, d, e, f, something to represent the constant. Or if I have x1, that's generally a constant, or x2, generally a constant, or let's say a or b. Generally, we use this to represent constant. And for next x, y, z, these, we generally use these three to represent. Okay, so in this case, x to the power of a and a to the power of x, only one variable, so it's an unary operation. All right, let's interpret this. X to the power of y, x to the power of 3, 3 to the power of y. Quick question. Which one is binary? Which one is binary operation? First one or second one or third one? First one, good. Very good, first one. Because first one has two variables. Second one and third one, only one variable, all right? So basically, x to the power of y, basically two variables, x and y, undergo operation, something to the power of something. X to the power of 3, basically one variable, x undergo operation, something to the power of 3. One variable, y undergo operation 5 to the power of something, all right? That's how we interpret this operation, okay? That's basically the summary of what we just covered. Linear operation, x minus 2 is a linear operation, but 2 minus x is not a linear operation because you minus x is a variable, so it's not a linear operation, right? Power, x to the power of y, power operation, for example, x to the power of 2, or exponential power, exponential operation, 3 to the power of x, okay? That's pretty much what we just covered. These are just all the concepts, all right? Okay, third and reciprocal power, okay. So x to the power of 3 is equal to y, so input is x, so the operation is something to the power of 3, output is y. Okay, now to define its inverse operation, mathematicians invited two ways of writing. One is the third, right? The second is power. Basically, 3 square root of y, 3 root y is equal to x. Y to the power of 1/3 is equal to x, right? That's the formula. Any question with the formula? No? Basically, that's the thing you need to memorize, all right? So we generally define if x to the power of a is equal to y, and then y is equal to the y, then y to the power of 1/8 is equal to a squared. A squared root y is equal to x, all right? That's the formula. Now, let's convert the following. X to the power of 1/3, square root of 2 minus x, 3 minus x to the power of 1/4, 2 minus 3x to the power of 1/2. x to the power of half and 2 minus square root of 3x. Now we need to convert this. Okay, so let's do the first one. X to the power of 1/3 is equal to, any idea? Can anyone yell out the answer? Third form. Sorry? Cube root x. Good. Okay, next one, square root of 2 minus x. Convert to the power form is equal to, can anyone yell out the answer? Noah, you want to give it a try? Okay, basically, if you look at here, square root of y, okay, if we convert to that, that's y, right? So in this case, y is 2 minus x, right? Okay, so basically, we'll just write 2 minus x. Okay, basically square root, if we don't have any number here, basically is square root, right? That's cube root, that's square root. Okay, so that's a. If we look at this equation, sorry. So in this case, a is equal to, for this question, a is equal to x. Okay, yes, that's the root symbol, right? That's a. So for this question, a is equal to 3. But for this question, a is equal to 2. Okay, so we have y is equal to 2 minus x. Okay, if we want to convert to this form, so y to the power of 1 over a. So a is equal to 2. So this is equal to 2 minus x to the power of y, sorry, 1 over 2. All right. Next one. 3 minus x to the power of 1 over 4. And we want to convert to the third form. So 3, we cannot do anything to the 3. X to the power of 1 over 4. So basically, in this case, so a is equal to, Noah? Yes. So it's 3 minus. Any idea, Justin? Yes, very good. All right, last one. 2 minus 3x to the power of 1.5 is equal to 2 minus, all right, 3x right, 3 square root of x. Basically, that's 1 over 2. So a is equal to 2. Basically, I can write a 2 here. But generally, we can ignore that 2, right? The last one, 2 minus square root of 3x, which is equal to 2 minus 3x to the power of 1 over 2. Basically, we use the formula. We use this formula. Jesus. We use this formula. I think you should have this formula on your formula sheet, but it's good to memorize. Memorize this formula. It's very useful. You're gonna use this formula a lot when you do your exam, all right? These are just the rules. This is just the rules you need to memorize, all right? We're not gonna prove or show that how this equation work. That's the mathematicians, that's their job, not our job, okay? Our job is to learn how to use the equation. Just like when you drive a car, you don't need to learn how to make a car. You don't need to learn how to design a car from the scratch. You just need to learn how to drive it, all right? All right. Let's move on. Reciprocal and the negative power. Okay. For the reciprocal and negative power, let's say if we have 1 over x is equal to y, so the input is x, the operation is 1 over something, basically that's reciprocal, and the output is y. So we know that 1 over something is not a linear division. We already discussed this before because we use 1 over x. It's divided, but x is a variable, it's not a constant. So it's not a linear division, but we also don't want to define a new operation for this purpose, right? So basically, people find that it's the same as a power, so we can define x to the power of -1 is equal to 1 over x. Again, it's just a formula. Any of you done general math before? General math or year 10 math? I believe that's in year 10 essential math, okay? When you learn quadratic. X to the power of -1 is equal to 1 over x. Okay, so generally, x to the power of -a is equal to 1 over x to the power of a. I'll give you a quick example. Let's do this. X to the power of, let's say, 10. Let's write this in reciprocal form. So it's equal to 1 over x to the power of, sorry, that's -10. To the power of what? Noah, any idea? Look at the equation. So the equation is here. X to the power of -a is equal to 1 over x to the power of a. So in this example, what's a equal to? 10, right? So it's equal to 1 over x to the power of, good. So basically you just put that 10, remove the negative sign, put the number here, right? All right, that's a quick example. Now let's do this. Convert the followings. X to the power of -1, easy, 1 over x, right? Now, next one, 3 over x is equal to, convert to the power form. Any idea? Very good. 3. Okay, let's do this. Basically, 3 over x is equal to 3 times 1 over x, and it's equal to 3 x, 1 over x is equal to x to the power of -1. All right, that's the full process. All right, next one. 3 over x to the power of 2. Emily. 3x to the power of -2. Very good. 1 over x minus 1 to the power of 2. Convert to the power form. Sean. Can you see it? Yeah. No rush. Check the formula. We have formula here. Okay, that's right. That's all right. Basically, we see this as a whole part. Okay, basically that's your x, and that's your a, right? Power of 2 is a. Basically, it's x minus 1 to the power of -2, right? Let me do this. X minus 1 to the power of -2. Let me highlight this for you. That's your x minus 1. That's your x minus 1. All right, and that's 2. Is that clear? Yeah. Okay, cool. No problem. Next one. 2 times 2x to the power of -2. All right, Justin. Good. 2 over 2x to the power of 2. All right. Okay. All right. Next one. Combination. All right. Combination. Sometimes you need to do this together. All right. So basically, that's an example. Let's say if we have 1 over square root of 4. All right. Basically, we use the formula we learned before. Okay. A root y is equal to y to the power of 1 over 8. Sorry, 1 over a. So square root of 4 basically is equal to 1 over 4 to the power of 1 over 2. All right. And it's equal to 4 to the power of -1.5. So what we just done, basically, we combined this set of formula, this set of formula here with this set of formula. we combine these two. All right. Any questions? No? Okay, let's move on to the example. Convert the following: 2x to the power of -1/2. All right, Noah, any idea how to convert this to the reciprocal form and it's with the square root?
2 over x power 1/2.
Good, very good. One more step. I need a square root. That's a good move. Keep going. Can you remember the formula? No? Okay. Let's go back to here. This is the formula. Okay, I will write it down. I'll just write it down here. y(1/a) is equal to square root. Sorry, not square root, a root y. Now I need the root. How to convert x to the power of 1/2 to the root form, to the third. Very good. Very good. You just need more practice. You know how to use the formula. You just need more practice. All right. All right. Next one. 1/2 square root of x is equal to, basically, we can write as 1/2 times 1 over square root of x is equal to 1.5 times x to the power of -half, right? And 8x to the power of -1/3 is equal to basically 1 over square root of, not square root, 3 root 8x. Not square root, sorry, 3 root. All right, any question? All clear? All right. Okay. I'm pretty sure you have this, page 7. If you don't have this exercise, I'll ask Betty to print it out. Do you have this exercise? Don't worry about it. I'll ask Betty to print it out. I highly recommend you do all these exercises just to build up fluency, all right? Just to build up the fluency, all right? When you do your exam, other students may take 10 seconds to figure it out, and you just need to take 2 seconds, all right? Yes?
Are we converting it?
Sorry?
Are we converting?
No, you do it at home. That's for your practice at home, homework, right? Not in the class. Right, so I strongly recommend you do this practice at home. When you do your exam, you can solve questions faster. Same with this. Same with this. If you already have this in mind, you don't need to use your calculator. All right, I'll give you an example. Okay. Without using calculator, can you find this? 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Any idea? Do you have a calculator? All right, 4,225. Okay, I'll show you the trick to calculate all these kind of things. Okay, from 15 times 15, 25 times 25, all the way to, let's say, 85 times 85. This one is equal to 225. This one is equal to 625. The next one is equal to 1225. 0 to 2. Okay, wait, that's 35 by 35. This one is 45 by 40. Sorry, 45. This one is 7225. Can you find some pattern? All these answers, the last two digits of these answers, they all end up 25, right? That's 25, 25, 25, 25, 25. Believe or not, 55 by 55 end up 25. 65, 65 end up 25. All right. Can you find some pattern about this? 2, 6, 12, 20, 72. No idea. Right. Now let's break it up. 2 is equal to 1 times 2. 6 is equal to 2 times 3. 12 is equal to 3 times 4. 20 is equal to 4 times 5. 72 is equal to 8 times 9. Now, can you find any pattern? Okay, I'll give you a hint. The 10th of 15 is 1. The 10th for 25 is 2. The 10th of 35 is equal to 3. Basically, you use that's the 10th. Does it make sense now? All right. That's something you could, but it's up to you. You're allowed to use calculator anyway. But think about how long it will take to enter 25, 5 times 2, 5, enter. But if I know the trick, 1 second. 1 second, right? Same. That's the tens. The tens is 2. Basically, that's 2. That's 2 plus 1. Right? That's tens is 3. 3. That's 3 plus 1. All right, same. 8. That's 8. This one is 8 plus 1. Basically, it can save you a lot of time when you do your exam. If you have more time, you have more time to check your answer, to check your calculation. I've read the VCAR 2024 Math Method External Report. One common mistake is when students transfer the answer from calculator to the exam paper, they make a mistake. If you have more time, you have more time to check. All right, that's the trick. But it's optional. It's up to you. You don't have to use that trick. Same. If you can memorize some of these numbers, like 2 to the power of 1, 2 to the power of 2, to the power of 3, 4, 5, 6, 8, 9, 10. It saves you a lot of time to use calculator, to type the calculator. All right, that's the trick. Okay, practice this at home. That's for you to practice. All right. All right, let's have a 5 minutes break. But before we have a break, I just want to tell you something. When you learn math, first thing, ask question. Second thing, practice. No matter what you learn how to drive, you need to practice. Does anyone have a drive learner permit? Yeah. When you learn how to drive, you need to practice, right? You need to have 120 hours practice, the logbook, right? Same. When you learn math, same thing. You learn how to play basketball, how to play instrument, dancing, singing, same. You need to practice. And in my class, there's no silly question. You can ask any question you want. You can ask any question you have because you're learning. It's good to make a mistake, okay? I'm a teacher, but I cannot read your mind. I'm not a mind reader. If you don't ask questions, if you don't make mistakes, I cannot read your mind. I cannot get into your mind. So it's okay to have a wrong answer. And it's okay to ask any questions. All right, that's my class. I don't care what other teacher think, but in my class, no silly question. And don't feel shame if you have wrong answer. Right? All right, let's have a 10 minutes, 5 minutes break.
You want to go to the toilet? You're right. How is the class? Is it hard or is it okay? It's okay. It's okay. How about you, Krista? Do you understand? Really? Have we learned it before? How about you? We're gonna record this class and after today, maybe tomorrow or Wednesday, we're gonna upload the class on YouTube, so you can watch this class online. Okay, and for the notes, we also sent you guys the PDF version. Then yeah, you don't worry to take everything. We can send you the digital version. Yeah.
All right. Right, let's, yeah, all right. Right, let's move on. So for the formulas, basically, or unfortunately, some formula we can use some technique to memorize, especially when we move to module 3 circular function about sine or cosine. We can use graph to help us to memorize some of the formula. But some of the formula, we just need to memorize without any technique, right? We just need to memorize all the formula. Or of course, you can always refer to your formula sheet. But again, if you always check your formula sheet back and forth, it's just waste your time in the exam, right? So some formula, okay. Here's how I memorize formula. If you have enough practice, you don't need to memorize it. It's all in your mind, right? Just like how you learn driving, all right? How to shift the gear. It's just built up in your mind, muscle memory. Same with the formula. If you have enough practice, it's gonna build up in your mind. You don't need to memorize it. You just naturally memorize all the formula, right? So practice. Okay. Now, let's have a look of this question. Solve A, where 2 to the power of minus 3 plus x is equal to a times x to the power, 2 to the power of x is equal to a times 2 to the power of x. All right. Any idea how to do this? I'm pretty sure you learned this before. You know the formula, but you probably just can't remember how to apply the formula. All right. I'll write this formula for you. Okay. Anyone remember index law? Index law. What can you remember? Index law. Anything? Okay. A to the, basically for index laws, a to the power of m times a to the power of n is equal to, Noah, you know the formula? Good. Okay. Now, Noah, can you try to use that index law? I can tell you that's the only formula you need to use to solve this equation, to solve this problem. Any idea how to do it? Could be wrong, that's fine. No, okay, that's fine. It's okay. If you don't have any idea, that's fine. Yes?
2 to the power of -3 plus x divided by 2 to the power of x.
Mm-hmm. Yes. Okay. You're right, but basically I'll write this way. You're correct, but I'll just write different way. Okay. For the left-hand side, we have 2 to the power of -3 plus x. All right. So now we can break it up. We can break it up, which is equal to 2 to the power of -3 times 2 to the power of x, right? Based on the index law, we can break it up, right? Which is equal to 2 to the power of -3 is equal to 2, sorry, it's not equal to 2, it's equal to 1 over 2 to the power of 3 times 2 to the power of x, which is equal to 1 over 8. 2 to the power of 3 is equal to 8 times 2 to the power of x. Now, let's see what we have on right-hand side. For right-hand side, we have 8 times 2 to the power of x, which is equal to left-hand side. Left-hand side, we have 1 over 8, 2 to the power of x. So a is equal to 1 over 8. All right. If I give you the solution, it's easy. But let's think about how we get started. All right. If I tell you the solution, it's easy. It's very straightforward, right? But let's think about without the solution, how we get started. So basically, for this question, on the left-hand side, we have a base of 2. On the right-hand side, we have a base of 2, right? Left-hand side, we have 2 to the power of something plus x. On the right-hand side, we have 2 to the power of x, right? So basically, we have same base. The base is 2. And the power is different. But we can see something that common. All right, that's how we get started. Then after we see these patterns, we need to try to basically split this to get something left-hand side equal to something right-hand side. And then we calculate A. That's how we think. Any questions? Any questions? Noah? Sean? No? Okay. All right, let's move on. Let's move on. Okay, that's the index law, basically all the power algebra formulas. Okay. I'm not too sure if this included in your formula sheet. Maybe not. Is it included in your formula sheet when you do the exam? Probably. Anyway, these are the formulas you need to memorize. And not just memorize, you need to know how to apply this formula, how to use this formula. All right? Basically, basically, if you have same base, base same, you add or subtract the power. Depends on you want to multiply or divide. If you have a different base but same power, all right, the power is the same, you multiply the base or you divided the base, okay? And m to the power of m bracket to the power of n basically is equal to, sorry, a to the power of m bracket to the power of n is equal to a to the power of mn. All right, that's basically the formula you need to memorize. All right. I think I'm gonna skip this. That's basically this show you how to derive the formula. All right, a to the power of m over a to the power of n is equal to a to the power of m times 1 over a to the power of n. All right, basically we use the formula we learned before to derive this formula. All right, 1 over a to the power of n is equal to a to the power of negative n. That's the formula we just learned before. N is equal to a to the power of m plus negative n, which is equal to a to the power of m minus n. That's how we derive the formula. You don't need to worry about how to derive the formula. It's just to show you that's where this formula from. All right. All right. Now, let's talk about simplify. All right. Basically, math simplify is not a precise word. Okay. So simplify can include few things. All right. When we talk about simplify, it could include combine something, all right, or expand something, or standardize something. Okay, it could include these three things. Okay, combine basically means letting a non plus minus times divide operation to be placed at the algebraic process. All right. Don't worry about this. Basically, for example, let's see this. Combine multiplication with same power, okay? So this one, basically, this slash means divide, okay? This slash means divide. Basically, you require to write square root of x over square root of 3 over square root of 6. Basically, or I can write square of x divided by square root of 3 divided by square root of 6. All right. You know, when you type, okay, let's say if you want to use Chat GPT to solve x divided by, anyway, 2.5. X divided by 2.5 is equal to, I don't know, 6. If you want to type on your laptop or computer, basically you need to type x slash 2.5 equal to 6. All right. So write this in the form of square root ax. A is in real number, right? R is for real number, okay? So how to write this? Remember, we have this one is equal to, let me write the equation here. A to the power of m divided by b to the power of m is equal to A over B to the power of M. All right, so this one basically is equal to x to the power of half divided by 3 to the power of half divided by 6 to the power of half, which is equal to x divided by 3 divided by 6 to the power of half, which is equal to, okay, square root of a times x. So square root of, wait, let's just do this, which is equal to x over 18 to the power of half, which is equal to square root of x over 18, which is equal to square root of 1 over 18 times x. Any questions? Basically, in the exam, you will not see any question like this, but you need to use the technique or formula we used in this particular question to solve a big question. All right. There's no question, just one question to test this particular knowledge, right? Can I move on? Yes? Okay. Now, this one, a to the power of 5 times 3 to the power of 5 divided by 2 to the power of 5. Write that in the form of m times a bracket to the power of n. And m is in real number and n is integer. All right. So the formula we need to use is a to the power of m times b to the power of m is equal to a times b to the power of m. All right, a to the power of m divided by b to the power of m is equal to a divided by b to the power of m. All right, so basically, that's the formula we need to use. A to the power of 5 times 3 to the power of 5 divided by 2 to the power of 5 is equal to, they all have to the power of 5. So it's a times 3 divided by 2, right, to the power of 5, which is equal to 3a divided by 2 to the power of 5. So in the m times a form, which is equal to 3 over 2, 3 over 2, a to the power of 5. Basically, m is equal to 3 over 2, n is equal to 5. All right, any questions? No? All right. For example 12, I'll leave this as a homework. You will get this file after this class finish, and I'll circle it, go home, and try to do it by yourself. All right, try to do it by yourself. That's example 12. Okay, let's move on. Let's move on to expand. Basically, all the example here is combine. Combination, right? Combine something together. Here, we're gonna start expanding things, all right? Basically, expand means you break up something. You break up something, all right? Let's have a look of this one. write square root of 32x to the power of 5 in the form of a x to the power of m bracket times square root bx, a and b in integer. All right. Now, let's have a look how to break it up. So basically, we have square root of something. We have square root here. We have square root here. We have square root here. And then we need something times x, right? Something times x. Okay. And we have a x to the power of m. Right, now let's break it up. When I break it up, square root of 32x to the power of 5, right? Now, when we break it up, 32 is equal to, because what are we looking for, right? We need to take out something, right? We need to take out something. We need to take out ax to the power of m, right? We want to take out something, take out from square root. Think about if we want to take out from the square root to get an integer, right? We have 32. How can we break up 32? We break, yes.
16 times 2.
Good. Basically, we break up 32 to 16 times 2. Because 16, if I take square root of 16, which is equal to, good, right? Basically, we want to square root something and get an integer. And we have 32. We need to break up 32. 32 is equal to 16 times 2. Square root of 16 is 4, right? Okay. 32 we break up as 16 times 2. Okay. X to the power of 5. Okay. We need to break it up. And square root, we need to break this up to 2 terms. And the square root of 1 term is equal to x to the power of something. How can we break it up? If I square root x to the power of 4. All right, let's see. X to the power of 4 times x. Right? So 32 x to the power of 5 actually is equal to 16 x to the power of 4 times 2x. Does that make sense? Basically, we have 16 x to the power of 4 as one group, 2 and x as another group or term, 2 terms. All right, now let's do this. Don't forget the square root, okay? This one is equal to square root of all right, we just break it up on the right-hand side. Now we need to take out something, right? We need to take something out. But before we take it out, we need to break it up. Oh, that's all right. Is that alarm? Is that a fire alarm? Your phone is about to catch fire? Okay, it's not a good joke, I know. All right, times square root of 2x. Right, that's how we break up the square root. Right, now you can see square root of 16 x to the power of 2 basically is equal to 4x squared times square root of 2x. Okay, so if we want to find A is equal to 4, M is equal to 2, B, sorry. What? B is equal to 2. All right. Again, if I give you the solution, that's definitely not hard. But think about why we want to break up 32 to 16 times 2, and why we break up x to the power of 5 equal to x to the power of 4 times x, right? Instead of, we have different ways to break it up, right? I can break it up as a x to the power of 3 times x power 2, right? I can break this up as 32 is equal to a times 4, right? Think about why we break it up like this instead of this, right? All right. Any questions? No? Sean, you good?
Yeah.
Tired?
Yeah.
You want to have a break?
Yeah.
All right, just feel free to have a break, but we have to continue. But if you want to go for a walk or have some fresh air, just feel free to go. All right. Okay, now question 14. Expand. Write this in the form of ax to the power of b, and ab is in the real number. Okay. So basically, that's cube root. Color. Cube root 64x to the power of 5. We can write it in the different form, right? We can write a different form because the form required is this. That's the form the question is asking for. So we need to write it in power form. So it's equal to 64 x to the power of 5 bracket to the power of 1/3, right? Basically, we're looking for a bridge. It's like a bridge. It's like a bridge. We have this, we have this. We need a bridge to connect these two. We're looking for a bridge to connect these two, right? Okay. Next, we break it up, which is equal to 64 to the power of 1/3 times x to the power of 5 to the power of 1/3, right? 64 to the power of 1/3. Any idea what's the 64 to the power of 1/3 equal to? Good. Right, so basically if they're asking for a, basically a is equal to 4, b is equal to good. Okay, let's move on. This is your homework. All right, this is your homework. Example 15 is your homework. All right. What about this? All right. I'll quickly go through this. I think we've already gone through this. Okay, I'll skip this question. It's been done. And this one is your homework. All right, this one is your homework. Example 16. All right, let's move on to the next part. Right, this in power form. I'll just quickly go through. Right, so So basically, bracket 1 over square root of 2x to the power of -5 is equal to bracket 2x to the power of -1 over 2 to the power of -5, which is equal to 2x to the power of. All right. I have a question for you. Just quick question regarding notation. What's the difference between? Are they same? Okay, good. Some students really confused about these two. All right, if you know they are different, that's good. Okay, and that's your homework. Try to do it at home. If I give you the solution, it's easy, but it's really hard to get started. All right, without the solution, it's really hard to get started. You need to practice. Now, evaluate. Can you evaluate this without using calculator? Yes, we can. I'll quickly go through, all right? 16 to the power of -5 over 4 basically is equal to bracket 16 to the power of 1 over 4 bracket to the power of 5 bracket to the power of -1. Right? That's how we break it up. So we have 2 to the power of 5 to the power of -1. Basically, it's 1 over 32. Okay. If you're confused about how we get this step, okay, I'll just write it here. 2 to the power of 4 is equal to 16, right? 16 to the power of 1 over 4 is equal to 4 root 16 is equal to 4 root 2 to the power of 4, which is equal to 2 to the power of 4 times 1 over 4, which is equal to 2 to the power of 1, which is equal to 1. Okay, if you don't know how I get from here to here, this is the full solution. Sixteen to the power of 1 over 4 is basically is equal to 2 to the power of 5. Oh no, 16 to the power of 1 over 4 basically is equal to 2. And then we have a power of 5. Right? Any questions? Now are you good?
Yeah.
Okay. Okay. Homework. Homework for this one. Okay. Homework for this one. Practice. Just quick summary. So basically, that's what we covered just previously. We have this, and some special. 0 to the power of a is equal to 0 when a is not equal to 0. 0 to the power of 0 is undefined. A to the power any number to the power of 0 is equal to 1. And 1 to the power of any number is always equal to 1. All right. That's basically a summary. Any questions so far? No? Okay. Now, I'll probably use this as a homework. That's basically a practice of what we just learned. Okay, homework. This is homework as well. This is a past exam paper. This is a question from a past exam paper, right? These two, homework. All right. Let's move on. Next, we're gonna do power algebra with quadratic, all right? With quadratic. All right. If we look at this function, right? If we look at this, not function, sorry, it's not a function, it's an equation. Is that looks quite similar with that format? Something square plus something minus a constant is equal to 0. Can you see the link between this equation and that format here? Can you link these two? All right, let's have a look. All right. Basically, that's a quadratic. All right. Okay, let's break it up. Let's say, let e to the power of x is equal to x. Okay, let e to the power of x equal to x. Now we break it up. Oh, sorry. So when we break it up, e to the power of 2x is equal to e to the power of x bracket to the power of 2 plus 3 times e to the power of x plus, minus 4 is equal to 0. So e to the power of x is equal to x, or we can use, we can use a. Let's use a, all right? You can use x, a or b. It doesn't really matter. Let's just use a. Let's e to the power of x equal to a. So this equation will be a squared plus 3a minus 4 is equal to 0. Right? Now, can we solve this? Can we factorize this equation? Are you guys confident with factorizing? Cross method? All right. Let's factorize this one. So it's equal to a plus 4, a minus 1. Cross method, factorize, is equal to 0, right? That's year 10 math. Right, so we have a is equal to -4 or a is equal to 1, right? That's the null factor law. Right, now we have two options. So because a is equal to e to the power of x, so we have e to the power of x is equal to -4. E to the power of x is equal to 1. Now, can we take both answers? Can we take both answers? All right, here's the thing. If a is equal to -4, e to the power of x is equal to -4. This one not exist, or I can say undefined. Why? because let's see the graph. Y is equal to e to the power of x. Can that be negative? You will never get negative. It's always greater than 0, right? So this one is undefined. So if a is equal to 1, e to the power of x equal to 1. So if we go back here, oh Jesus. Equal to 1, so basically x equal to 0, because anything to the power of 0 is equal to 1, okay? E to the power of x must greater than 0. All right, any questions? No? Okay, basically let's summarize what we've done here. Basically we link the equation to a quadratic, okay? We link the equation to a quadratic. We split this, we basically break it up to e to the power of x, bracket to the power of 2. And we let e to the power of x equal to a, and this is a quadratic. This is a quadratic. Okay, quadratic. And then we factorize. And then we solve. And then we find the final answer. Choose. All right, that's the general process, right? All right, I will give this as a homework. Basically, you use the same concept. So that's your homework. That's your homework. Okay, this one. Homework. Try these two for homework. Right, these two for homework. Okay, try your best to do it. Try your best to do it. But if you struggle, next time, next class, bring it to me. We can go through together, all right? But you really need to give it a try. You need to try, you need to practice, all right? Okay, let's move on to graph. Let's move on to graph. So when we talk about graph, we have something like a basic graph. What basic graph mean? Y is equal to square root of x, or I'll write one more. Y is equal to, let's say, x squared. That's basic graph. Or y is equal to 2 to the power of x. Y is equal to log ex. Y is equal to sine x, or y is equal to cosine x. Y is equal to tangent x. All right, that's what we call basic graph. What is not a basic graph, for example, not a basic graph include a transformation. Have you learned transformation? Yes? Noah, have you learned transformation? Yeah, transformation. For example, let's say y is equal to 3 sine 2x plus pi over 2 plus, anyway, 10. That's definitely not a basic graph. Basically, you can get this. Okay, so what I'm trying to say here is if you have all these basic graph in your mind, you can use the basic graph to get this non-basic graph. And also, when you have basic graph in your mind, it really helps you to solve question and memorize formula. All right, it really helps you. Especially when you move to module 3, 4, 5, 6, if you will see sometimes I just use graph to get some idea, to get some answer. So graph is very useful. I strongly recommend you have these graph memorized. All right. Okay, let's have an example. Plot y is equal to square root of x and y is equal to -2 square root of x plus 1 plus 8 using point substitution. Okay. So what we have here, let's say y is equal to square root of x. Okay. X is equal to 0, 1, 4, 9, 16, 25, and y is equal to 0, 1, 2, 3, 4, 5. Right? So we have 0.00 1, 1, 4, 2, 9, 3, 16, 4, 25, 5. Okay, then when we plot the graph, okay, I'm not an artist, so the graph I'm going to draw looks pretty bad, especially on iPad. All right, I'll try my best. Okay. All right. Let's say that's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Oh, Jesus, I need more. Okay. $22, $24, that's $26. All right, and that's 2, 4, 8. All right, so we have 1, 1, so it's somewhere here, and we have 4, 2, 4, 2, 9, 3, so 9 and 3 is here. 16 and what? 16 and 4. 25 and 5. Wait. That's 6. 25 and 5. And we have 0, 0. So the graph gonna be like this. Right? That's how we usually draw the graph. And if we want to draw y is equal to -2 square root of x plus 1 plus 8, all right, we have y is equal to -2 square root of x plus 1 plus 8. And we have same thing as x is equal to -1, 0, 3, 8, 15, 24. And y is equal to 8, 6, 4, 2, 0, -2. So we have point -1, 8, 0.06, 0.34, 0.82, 0.15, 0.24, -2. Okay, so basically, I'm not gonna draw in detail, but basically the graph we're gonna have looks like this. Okay, in the next few class, if I ask you to draw the graph, sometimes I just need to draw the tendency and the key points. Okay. Okay, let's say it looks like that. I know it looks pretty bad. It's too bad, way too bad. All right, and this point is a -1, 8. All right, and we have, I know this is not in scale, but okay, let's say this one is -1, 8, and this one is 15, 0. Okay, that's how you draw the graph. Okay, you have all the x and y coordinate, x, y, and points, and you basically use a line to link this point together. That's how you draw the graph. But I want you to memorize this. I'll explain how this works. Basically, it includes all the graphs you need for for the method, right? If you can memorize this, believe or not, when you learn module 3 is circular function, so it's not about these graphs, but when you learn module 4, 5, and 6, if you have this graph in mind, you can solve question quicker than others. All right. Basically, all these graphs x to the power of n over m. Okay, x to the power of n over m. If we have n over m more than 1, and n is odd number, m is an even number, then you have a graph looks like this. Okay, it's definitely not a perfect graph, but it definitely shows you what the graph looks like, the shape of the graph, the shape of the graph, and where the graph starts. And also, I will mark the key point. All these graphs, except these 3, okay, except the 3 on the right-hand side, will pass the point 0, 0, and 1, 1. Same, 0, 0, 1, 1. Same. Okay, these are all same. They all pass 0, 0, and 1, 1. Okay. If n over m more than 1, and n is an odd number, m is an even number, you will have a graph like this. All right. If n is an odd number, m is an even number, but n over m is between 0 and 1, you will have a graph like this. Okay. If n is an odd number, m is an even number, n over m is less than 0, you will have a graph like this. Same here. If n is an even number, m is an odd number, n over m is more than 1, you will have a graph like this. For example, x to the power of 2 over 1 basically is x to the power of 2. It's a it's a parabola, right? It looks like this, right? Another example, x to the power of 1 over half, right? N is odd number 1 and m is even number. And 1/2 is between 0 and 1. Basically, that's the square root of x. That's the graph of square root of x, right? Another example, I'll give you another example. Let's see the last row, first column. N is odd, M is odd number, and N over M is more than 1. Let's say x to the power of N is odd, 3 over 1 is odd, is equal to x to the power of 3. Basically, x to the power of 3 looks like that. All right, but it's just show you the general shape, okay, general shape, okay, and I strongly recommend you memorize all these. I have the GeoGebra on my laptop, but I cannot show it to you. Anyway, let's do it later. Let's do it later. All right, I strongly recommend you memorize this. Here are some tips about how to memorize it. Okay, see the blue line? Okay. Oh, for the first row, okay, you only have the graph on the right-hand side of the y-axis. There's no graph on the left, right? For the second row, you have same. You can see the shape is the same, but you have graph on the left-hand side. Basically, it's a symmetry with the y-axis. Okay, for the last row, same, blue, 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 same, pink, 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 same, green, 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 same, but it's a central symmetric, right? So basically, we'll rotate 180 degrees based on the original point to get the second half of the graph. That's how I memorize this, right? Try to memorize this, believe it or not, it will help you a lot in your exam if you have this in mind, right? Let's quickly do this. Let's quickly do this. Okay, for this question, when I ask you to plot the graph, you don't need to give me a perfect graph. You just need to show me the shape and some key points. Let's have a look at this. I cannot plot all of them. Let's just do a few examples. Let's plot y is equal to x to the power of 4/5. All right. So 4/5 is between 0 and 1, right? It's between 0 and 1. And 4 is even, 5 is odd. So you will see. So it's in this, basically in this column, because it's between 0 and 1. And 4 is even, M is odd. So the graph will look like that. Okay. So the graph will look like this. And this point is 0, 0. Oh, it's not a good graph. Okay. Okay, in your exam, if you have a great paper and the question asks you to plot the graph, you need to have a good graph. You cannot just plot the graph like this. But sometimes, or most of the time, if you want to use graph to help you to solve a particular question, you don't need to have a perfect graph. Okay, you just need a shape, tendency, key points, that's it. All right, does it make sense? Okay, if the exam question asks you to plot the graph with the grid paper, with all the numbers 0, 1, 2, 3, 4, then you cannot just draw like that. That's not, you will lose mark, more than half of the mark. Okay, but if you want to use this to help you to solve, let's say, a multiple choice question, but you need to do some calculation. But if graph is easier, you have graph in your mind, then you just draw the graph like this. Okay, you will see in module 5, 4, 5, and 6. You will see I use a lot of graph to solve problem. All right. Okay, I'll leave the rest as a homework. So these are homework. Okay, you don't need to give me a perfect drawing, just the shape, key points. And also the practice here, sketch the graph for the following equations. All right. I really want to go through this. Where is it? Okay. I just spent 5 minutes to quickly go through this. Okay. Sketching use the points. I will skip the method 1. I will not sketching use the points. I will use the mapping method. Okay, mapping method. So the basic form, y is equal to, the basic form for this equation is y is equal to square root of x. That's the basic form. Let's think about transformation. Okay, so for this equation, the point need to pass 0 and 0, and 1 and 1. Right? Okay, now let's think about what we have here. So for the x part, we have x plus 1. That's for the x part. So x plus 1 is equal to 0. X equal to -1. And x plus 1 is equal to 1. Okay, basically we substitute this number. And x equal to 0. Okay, and for the y part, we can just assume, okay, this one, we just treat this as a y. We just treat this as a y, okay? Basically, if square root of x plus 1 is equal to y, 2y minus 8, right? Basically, that's 2y minus 8. Basically, that's my y part. That's my y part. Okay, so for the y part, let's say, use that color. 2 times 0 minus 8 is equal to -8. And 2 times 1 minus 8 is equal to -6. Okay. That's my y part. Okay. So basically, we don't need to substitute all these points. We can find all the points, and that's the graph. That's the basic graph. So the basic graph is something looks like this. 0, 0, 1, 1. But after the transformation, we have x is equal to -1, y is equal to -8. So we have -1, -8, somewhere like maybe, I don't know, maybe here. -1, -8, and we have 0, -6. And the graph will be like, so basically that's -1 8. That's 0, -6. That's x1. All right, I know this is probably, you might think why we use that method, but when we move to module 5, especially module 6, module 6 is a transformation of a function. Okay, module 5 is the combination function, inverse function, things like that. When we move forward, you will see how this works, and you will see how this can speed up your problem solving process. All right, any questions? No? Sean? No? Noah? Emily? Justin? Okay, that's all for today's lesson. And I will upload this file. I believe you have a group chat or something. Anyway, you will get this file tonight. You will get it tonight. All right. Any feedback? Did I